This is lecture 11, example 2. This is another programming example. In this chapter or this lecture, we talked about kind of memory issues and certainly I/O. Super important, and we'll be doing a little bit of that in this example. And I might as well get going. Okay, so this is a standard example, and I'm going to do this one more time via starting a flowchart here, then switching over to Venus to do the typing, and essentially doing that because essentially it takes too long to write out, simply because when it says don't change any register other than don't permanently change any register, that means I have to save context. That means it's a lot of extra typing and writing, and I'm actually having trouble fitting it in this display here. So what I'm going to do is draw the flowchart here and then switch over to the end. Okay, so this is a program, or what does it say, right? Assembly language subroutine that counts how many values in memory are less than 1,000 and greater than FF, or 10,000. I don't know. It's a hex number. I don't know how to pronounce it. And so essentially, I'm looking at values in memory. I'm seeing how many of them are in a particular range. Now, I don't really know how many numbers I'm looking for. I'm going to keep looking until I find one that's 0. So when I find one that's 0, that's going to allow me to leave the subroutine. Okay, so this was going to be kind of an interesting flowchart. Essentially, I think I have to check 3 conditions on it. One, I got to check to see if it's 0, and I quit, and then I have to check to see if it's less than this number, and if it's less than that number, I have to ensure it's greater than that number. And so in the end, this is a count, and so it's I'm counting something, so I'm accumulating it, which means since essentially I need to start that counter off at 0. Most importantly here, it does tell me to protect the registers, save the context essentially, so I got to do that too, which is something I always do at the end of the program. So when I'm writing it, it's not a program, it's a subroutine. Okay, so let's do this. This is going to be we call it count. I don't know what I name it. Count range, and then I know I need to save context. Okay, so that's given by the problem. Once again, I don't know what the context is. It's the last thing I do in this problem after I do the problem. And so essentially it's just, look, it's typical subroutine stuff. I know there's initialization stuff I need to do, so there's my init stuff. And that's all I need to do on that one. Okay, so the issue here is I can actually model this as a do-while loop, because the stopping condition is based on getting some data, so I know I'm going to get at least one piece of data. So the very first thing I'm going to do in this program is to get some data, and then I'm going to look up the data. Should have said data. Data equals 0. Certainly, if the data equals 0, that means I am done, and I will come down here somewhere. I don't know. Restore context and return. I think that will fit in there. I'll just make it RET. Okay, so that is equals 0. Yes. Okay, so if it doesn't equal 0, that means I have to check the range on it, and we'll say what are we gonna say? So it has to be less than this. So I will say less than 0x1000. I'll say no. And then if I say no, I know I have to get out of that. I say yes. And then I have to check the other condition, and it's greater than greater than 0xff. If that's a no, then I have to get out of it also. And otherwise, I am going to do something like increment count, which is my loop counter, and then I can come up here and do some admin. And I think that's going to work here. I think that's going to be all I need to do. Certainly, if I don't, if I need to do something else, I'll put that in later. But yeah, that's the idea. This is a yes. Okay, so if it makes it through these three conditions, that's when I increment the loop, and I'm going to go ahead and call that done for now. And then I'm going to switch over to Venus, and it's going to be different. And then, like I said, this would probably be the last one I type out. And let's see this. So you kind of have to memorize the flow chart here. In fact, I'm gonna go ahead and write it down as I switch over to this thing. Okay, so this is the new video I'm going to put on the back end of this, and I'm in the Venus assembler. The first thing I want to do is put a couple notes in here. X10 equals the memory address. These are some notes from the actual problem itself. X20 equals the final count. Okay. So I think we called this CNT RNG, not a big deal if we got it wrong. Just the subroutine name. The first thing we need to do in the subroutine is save context, and I don't know what context to save until I'm done. But after that, I know I need to do some type of initialization and worry about that later. So I think I'm going to come down here and say store context also, and I'm done, just so I don't forget this stuff. So these were, major blocks in the flowchart. So I'm going to keep those in here. So saving context, like I said, I don't know what it's going to be, and so I'm not going to worry about it. But for here, I'll move this over a long way. I'm going to initialize some stuff. So this is a counter of some type. X20 is used as a counter, so anytime I have something like that, I'm going to start that counter out at X0. So I'll move X0 into that, which essentially clears the counter. I'll move this way over. Here's clears accumulator. Okay, so and this problem is kind of special because I need to make some comparisons, and what I need to compare it to is that 10000 has to be less than that. So I'm going to go ahead and put that in here. 0x00010000. That's a compare value, and I'll put another one here. Load immediate x26, which is the other value I need to compare to, which I think is FF. And so I'm pretty sure these are right. Now, I don't, I guess I could do this somewhere else. It just makes the problem easier because the compare, which is the branch statements, typically work better with two registers. I mean, there's other ways to do it, but that's just by far the easiest way. So this is going to be modeled as a do-while loop, because the stopping condition is if I input a piece of data from memory and it's 0, so I'm always going to be inputting at least one piece of data, and this is going to be the beginning of my loop, so that's going to be load word x30, doesn't matter what, 0, and the address is x10. So this is get data. Okay, and then the first thing I need to do is data, see if it's 0. BEQ x30 x0, and if it's 0, I'm going to jump to restore context. Okay, and then that's the first thing I need to check. If it's not 0, I have to see if it's less than 1000, which is the value I have in 25. So I can do BLT x30 x25. That's the mixing making that comparison, and I'm going to jump to an admin. And so essentially that's going to continue the loop iteration here. So I'm just going to put it, I like doing this so I don't forget. Admin, there's a label, it makes the red go away too. Okay, it's less than, has to be less than x25, it has to be greater than x30, x26. Okay, x26 was the other value I have right here, and if it's greater, if it's less than that, and greater than, let me get this right. Yeah, I'm confusing myself. Just less than, if it's less than that, jumps to admin, and I don't think that's right. I think that's going to be problematic. So let's fix that up. And so, you know, I could edit this mistake out, but I'm just simply not going to. So I'm going to say if it's, I'm going to change it greater than, okay, greater than, and less than, okay, I like that better. So if it's greater than x25, then that's bad. If it's less than x26, that's not what I'm looking for either. Okay, but if it passes both these tests, that means it didn't jump to admin. That means the value is greater. It's not greater than x25, and it's not less than x26. And this is the case where I'm going to increment the counter. Add immediate x20, x21. So that's my increment. Okay, so I could have done this in different ways, but this is the easiest way, and essentially it avoids a extra jump instruction. Okay, so if it makes it here, the admin part of this is to essentially it's just to add increment the address pointer, which is x. Where is it? x10. Because I'm working with words, I increment it by 4. And this is advanced. Pointer. I like saying pointer. It sounds like C code. Anyway, so at that point, I think I'm done. Just need to jump to the loop, and I think that's okay. So if it's greater than blah blah, if it's greater than blah blah blah, or less than blah blah blah, it skips the increment, and that's what I want on this thing. Okay, and then up here, if it breaks out of this loop, and that's when I'm done, I need to restore context, and at some point I know I need to return. So let's take a look at this program. And so this subroutine, so I'm using 25, 26, x30, and x10, and so I'm using 4 registers, and so I need to make space for those 4 registers on the stack. SP, 4 times 4 is 16. It's in the negative direction, and that's my make space on the stack. Okay, then I'm going to have 4 instructions here where I save those 4 registers. Save register. This is where the cut and paste comes in so handy. x25 0 x SP. It's a stack. We're working with a stack, and that's gonna push. I'll just say push. Okay, and then the cool thing is I can copy these things. I need to save 4 registers. I need to save x25, x26, x10, and I think x30. Okay, so those are the 4 registers I used in there. I got to get the addressing right, and I'm done with that. I have saved context. I initialized. I've got the loop there. I broke out of the loop, and this is always the nice part. I'll just go ahead and copy these. And restore context is very much the same, except they're load words. Notice, big cut and paste operation. I barely changed anything here, except the stack pointer. I need to adjust SP, 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 and it's in the other direction because I'm done with it. And I think I'm done. I'll get these comments right. And we'll say adjust stack. I'll just say stack pointer, and I'm going to call this done. I know this isn't fitting on the screen. That looks a little bit better. Hopefully this will be good and happy. And I am putting in a stupid comment. I always like putting in a stupid comment and return. Okay, and I think I'm gonna call this done. We'll see if it simulates. I could check through here, but I know memory's full of zeros and it would be pretty pointless. But yeah, this is the whole thing, and I know it's written in the solution of the PowerPoint too. I just don't remember what it is. I probably use different registers for all I know. But yeah, many ways to do this. This is the way I choose to do it. Pretty fun, huh?